All right, this is the second lecture in Module 8 on making plots. And this time we want to do what we call multiplots and 3D graphs. So most of you or some of you are in Cal 3, and you know that what you study in Cal 3 is vectors to start with, and vectors in 3D, and then you'll slowly begin to do, you'll start doing three-dimensional surfaces, three-dimensional curves and lines and that sort of thing. So there is, MATLAB does a great job of plotting those things. The first and simplest one to plot is a curve in 3 space. Now, you know, what you learn in Cal 3 is you might think, you know, you got an equation of a line in 2D, y equals mx plus b, so there might be something similar, z equals something x and y. That's not the way it works. That turns out to be a plane. You can't write a simple equation for a line, a general line in 3D. You have to parameterize it. And so the way that we do that is that we think of a vector, a position vector, with its tail at the origin, its head points to a point, and then you make all 3 of your coordinates dependent upon the same parameter. We typically say t, and in physics, that might, in engineering, that might mean time more often than not. It doesn't have to, it's just a parameter. But you plug in, you give me a t, and I can calculate what x, y, and z are. And then if t is continuous, then generally if you have simple functions for x, y, and z, you'll get a nice continuous curve called a space curve. The algorithm for plotting it in MATLAB is first you have to set up your vector t, your array. Then you have to calculate all 3 of these. Then you plot the curve, and you can add your different things to it. So here's where I did one. So my parameter is t. It's going from 0 to 12. I want 50 points. And my function is going to be, if I wrote it as r, it would be 10 cosine t I hat, 8 sine t j hat, 3t k hat. So x of t, notice I don't put enough t, not in a MATLAB statement. It's just x equals, because I'm using all these t's. So it's 10 cosine t. My y is 8 sine t, and my z is 3t. That, what you learn, we'll talk about in physics 2, well, we'll talk about in Cal 3, is that that's a helix. That might be the path of a charged particle in a magnetic field. But whatever it is, it's a helix in 3 space. Now you can, once you've got your plot window up, you can grab it and move it around and look at it from different vantage points. But the command is just plot 3. And then you give it your x, your y, and your z, and then you use the same things to label it. I put a grid on it, and that puts a grid in the 3 planes. That helps your eye visualize it. And then I just put x of t, y of t, z of t as my x, y, and z labels. Okay. Now, there's a couple of ways to do multiple plots. And one that we've already done. How do you put more than one curve on a given graph? And that's just the same plot command. You just put x and y pairs in. But it could be that you want multiple different, with their own grid and axes, and then we can put multiple plots in the same window. That's with a subplot command. And think of it as a matrix. You're dividing the page up into a grid, number of rows, number of columns. So subplot 2, 2, 3 would be 4 plots. Divide your window up into 2 rows, 2 columns. We're going to pick the third one, and it starts in the left and goes clockwise around. So a 2 by 2 would have space for 4 graphs. All right, I've got an example. You can download it from Module 8. It's called Sample Multiplot. And here it is. So there's where I set my x's up. From minus pi to plus pi, I want 100 points. On the first graph, I'm going to put sine of x. And here's how I do that. 2, 2 means I want 2 rows and 2 columns. 1 means the one in the upper left in the regular plot command, x comma y 1. Then I can grid and do everything I want to that graph. And then I'm going to do on the next plot 2, 2, 2, which will be first. You have to tell how many every time. I'm changing this third number. That means the second one. So that'll be the cosine. Then the third one will be the tangent, and the fourth one will be the exponential. So you can either download it and run it yourself, or you can type it in and run it, but whichever, you'll get this. So let's kind of inspect. For the first one I had subplot 2, 2, 1. I said plot x and y1, which is the sine, x label, y label, my name is the title, And so that's that one. So that's 1, 2, 3, 4. And so to get the next one, I did a 2, 2, 2, plot X and Y 2, grid, and you see I called it plot 2. And then that was, oops, too far back. That was him. To do the third one, it'll be 2, 2, 3 and 2, 2, 4. And you can see that there. So that way you can do multiple graphs. And so on the same figure. And then, of course, you would do a file save as and save it as a JPEG or a PDF to turn it in. All right, now you should be ready for 20, where I'm going to have you put 2 graphs in the same figure using subplot commands. And one of them is a 3D curve, and the other one just a regular plot. So let me know if you have any questions about it. See you in Module 9.